Here we're asked to find the maximum possible error in the volume of a cylindrical hole which has a diameter of 6 inches plus or minus 0.5 inches and a height of 4 inches plus or minus 0.1 inches. So the first thing we do is draw a diagram. So that's a cylinder. So this dimension here is going to be d plus or minus delta d, and then there's a height h plus or minus delta h. So the volume of the cylinder will be given by pi over 4 d squared times h, remembering we're working with the diameter and not the radius. So the first thing we do is we write down the total derivative. So that's dv, dt, dt plus dv dh. This formula is only exactly valid for infinitesimal quantities. So we need to say that when we're working with finite variations, using deltas rather than d's, this formula is only approximately true. And finally, we're looking for the maximum possible error. So we want to make sure that all our signs are positive. So now we have a formula which is at least approximately true for the maximum error. So the next thing we do is work out our partial derivatives. So dv dd, differentiating the d brings down a factor of 2, so we end up with pi over 2 dh, and dv dh, pi over 4 d squared. Substitute these into our formula. Delta B max is pi by 2 dh delta d plus pi by 4 d squared delta h. And now I've got this far, I can see I don't need modulus signs because every quantity here is positive. The last step is just to put the numbers in. That's pi by 2, 6 times 4 times 0.05 plus pi by 2, 6 squared times 0.01. Throw that into a calculator. My final answer is 2.17, and I must be careful not to forget the units. They're going to be inches cubed. At that point, we finish the question.